Okay. Right. So we are going to now look at what we have to identify. So we know that we first draw our transformation. Okay. So based on the view now, right? And the best transformation to use is based on the appendix. If the appendix says that this is X and this is Y, okay, we happen to select this is also our X and that's also our Y. So we draw our transformation first. Okay, so this is X, this is Y, and this is Z. Okay, then I'm going to sketch out our neutral axis. Okay, our neutral axis. So the neutral axis, which is the green line I'm going to sketch, this is the position of our neutral axis. Okay, that's our position of neutral axis. Right, so the green line they've just drawn, this is your neutral axis. Right. So from did I get that right? No, I think I got it wrong. Sorry. So this will be my X. This will be my Y. And this will be my Z. Yep. I think I'm awake now. Okay. Finally. Right. So from here, we know that we need to find stress in the Z direction. Right. So the parallel axis, the neutral axis, and the neutral axis is parallel to Z, right? So we know that we have to find the stresses in the Z direction. And this is going to cause by if we have any PZ over A, right? So this is due to axial loading. Then plus by MY over IYY multiplied by Z, right? This is due to moment about y-axis, and then plus by mz over izz multiplied by, sorry, not mz, mx, okay, mx over ixx multiplied by y. I do apologize, this is also x. I'm so used to the other way around. Okay, so this is moment about x-axis, right? So the good news is the ixx and iyy values are given. Can you all see that? So ixx, so we know that ixx is equal to 40.8 times 10 to the power 6 millimeter 4. So this is also equal to 40.8 times 10 to the power minus 6 meter 4. And we are also given that iyy, okay, is equal to 9.03 times 10 to the power 6. Right? So it's 9.03 times 10 to the power minus 6 meters 4. Okay? So that's the good news. You don't need to mess around with second moment of area. Then the next thing that we know, we also know our area. Right? So our area that is given is equal to 5320, right? Millimeter squared. So this will be equal to 5320 times 10 to the power minus 6 meter squared. Y times 10. So millimeter is times 10 to the power minus 3, right? Right. The first mini is the minus 3, and then the second is meter squared. So minus times 10 to the power minus 6. That's how we do it. Okay. So that is done. Okay. So what we know is we know this one, we know this one, we know this one. Hallelujah. Okay. X and Y at the numerator is all dependent on the element where we're interested. Okay, so this is done. Okay, so that's the easy part. Again, the most difficult part is what's your axial force, what are your moments. You can see that now, right? Okay, then the next thing that we're going to identify now, but the shear is pretty tricky. Okay, so next we have to look into the shear. So the shear, by looking at the shear forces are in two set of direction. Okay, so what do I mean by Eugene? The shear forces are. So if you look at Y, right, the 25 kilonewton is in the Y direction. If you look at X, okay, the 2 times 8 kilonewton is in the X direction. These are the forces that will induce shearing stress. Okay, so the shear is equal to Vx over Iyy Qy divided by the thickness. Or, okay, Vy over Izz, okay, Qz and T. Okay, so these are the, so again, no, wrong direction, Eugene. So familiar. Ixx Qx divided by T. Again, we know our Iyy, we know our Ixx. Okay, so for this case, right? For this case, there are things that are like important. Okay, which I'm going to wait. Hold on. I'm trying to do something. Okay. So what I've done down there, maybe it's too small on your screen. I've pasted the rules. Okay. Rule number 1, V and I are constant. Datum is at the centroid. Analysis of carried out from the Y variable maximum first moment of area region cannot cross. So these are the rules. Okay, just to recap some of your memories. Okay, so it's open book. Okay, it's open discussion exam. Not open discussion, but I can't catch you if you do discuss, right? So rule 1, rule 2, rule. So you need to get all this information ready. Then you can tackle a problem like this. Okay, or not is quite you are doing a lot. Okay, right. So the next thing now is let's start analyzing the stresses now. Okay, so we're going to analyze the stress. So this is the first time you guys are looking at this. It can be a bit confusing or a bit overwhelming, but it's understandable. Once you do some of the tutorial question, you'll find you'll get better. Okay, so I'm going to paste the diagram down here. Yeah, there's our diagram. Right. So that is our small. So the first thing we're going to do, I'm going to view this on the XZ plane. Okay, so we're going to view. So I'm going to draw a small transformation over here. So X, Y, and Z. So we are now going to view this structure now in the XZ plane. Okay. So draw your transformation. Right. And then you will have your rotation about Y. I'm using right hand rule. Okay. So rotation about Y. Okay. So you know where we are looking at. So we're going to draw the structure now. Okay. I'm going to draw the structure. So I'm going to draw the structure a bit. Yeah. Like this. Okay. Then with the next thing we're going to do, we're going to say where is element A. Right. And then we are going to construct our neutral axis. Neutral axis is so important. Right. So this is our neutral axis. Right. Then we're going to put in all our forces. Okay. So we have something somewhere around here. This is going in at 25 kilonewton. And then we have 8 kilonewton times 2. 8 times 10 to the power 3 Newton twice. And then you will have a vertical one coming in. And this is coming in at, oh, sorry, I'm colorblind. I can't see there was green already. Sorry. Okay, so we know that those are our forces. Okay, so that is our 100. Then we have our 8 kilonewton twice. Okay, times 2. And then we have the 25. Okay, so the first thing, so like what I said, do not analyze the dot and cross, right? So dot and cross, we don't analyze. So there are not a lot of dots and cross. There's only the 25. There's a dot. There's a cross. Okay, so we're going to see what were these 8. The 100. Okay, let's do the 100 first. Okay, so we know that. I think I have a question from someone. Is there someone asking me a question? Oh God, Chikisa. Right. So we will have the vertical one. Okay. So the 100 kilonewton, right, is acting on the neutral axis, right? The 100 kilonewton is acting on the neutral axis. So PZ will be equal to 100 times 10 to the power 3, right? So we know that this is going to induce a stress in the Z direction, right? Which is equal to PZ divided by A. And this on element A will induce a compression. So write this out already. Okay. So you don't need to worry about it or not. Did we do this or did we do? You start to get worried about it. Okay. Then from here we move on. Okay. Then we look at what can the 100 times 10 to the power 3 Newton do. Anything else? Nothing else. Okay. Let's look at the 80 times 10 to the power 3. So the 80 times 10 to the power 3 is going to induce a moment about the y direction, right? So the distance, so from here we mark down the distance. Now the distance is from the element. Okay, I repeat again, the distance is relative to the element. Okay, so from here, so we want to find the distance. Okay, and there's something else very important. I'll tell you guys later on. Okay? Once we get there, I'll tell you. Now there's too much things on my mind. So there's distance. Okay. And then, so we know the distance over here, right? So the distance over there is what? 600 millimeters. Okay. We look at the diagram. Is 600. So I'm going to call this as going this way. Okay, going in the anti-clockwise. Summation about moment, right? In the y direction. In the y direction, moments in the y direction at element A. So this will be equal to 8 times 10 to, so twice, because it's 8 times 10 to the power 3 multiplied by a distance of 0.6. So is there any other moment in the y direction? The answer is no. There is no other moment in the y direction. So this will be equal to 2 multiplied by 8 power 3. That's by 0.6. It's equal to 9,600 Newton meter. Positive means good. So once you know this, you can draw this, right? Right. So this will be under going through tensile and compression. And on element A, this is so before we go there, so we still want to calculate stress Z. So this one is equal to moment in the y direction divided by Iyy multiplied by x.